The next type of equation we're going to solve is going to be a dilution. Dilution equations are easy to figure out because they're asking for before and after. If we look through the question, I see that I'm going to have 500 parts per million to start. I'm going to end with 100 parts per million at the end. Knowing this, I have a before and after, and I'm going to need to use my concentration change formula. This, for those of you that don't remember, is CI VI is equal to CF VF. Now, as always, I'm going to list out what we have to start with. So I have an initial concentration of 500 parts per million. I do not know what my initial volume is, as that is what the question is asking for. I know that I want a final concentration of 100 parts per million, and I want a final volume of 2.5 liters. So this question is asking how much of this am I going to need to satisfy these end conditions. So let's plug these into our formula. 500 parts per million multiplied by an unknown amount of that solution will eventually equal 100 parts per million of a 2.5 liter solution. Now it's important to note when we're working with units, the units are irrelevant as long as they match. I have parts per million, I have parts per million, it works perfectly. If they were parts per billion, it would still work. If it was percent, as long as it was the same kind of percent, it wouldn't matter. As long as the units for concentration are consistent throughout, you do not have to change them to anything. So we're going to divide out both sides by 500. And when we look, we're going to see that our parts per million are in fact going to cancel out, leaving me with liters. That's what I'm looking for in the first place is volume, so this looks like it's going to go well. When I complete all of this math, I will find that my initial volume will be equal to 0.50 liters. This is also the way in which we would solve a solution prep question. However, we'll do another example of that in a moment.